This is Spacetime, Series 27, Episode 2, for broadcast on the 3rd of January 2024. Coming up on Spacetime, claims the Small Magellanic Cloud is actually two separate galaxies. A new study suggests the dwarf planet Eris could be squishier than expected. And NASA's new PACE satellite now slated for launch on February the 6th. All that and more coming up on Spacetime.
Welcome to Spacetime with Stuart Gary.
A new study claims that one of our nearest satellite galaxies, the Small Magellanic Cloud, is actually two separate galaxies, one behind the other. The findings, reported on the pre-press physics website archive.org, are based on a new study of stellar motion in the interstellar medium within the Small Magellanic Cloud. The Large and Small Magellanic Clouds are a pair of satellite dwarf galaxies which pass close to our own galaxy, the Milky Way. The Magellanic Clouds were known to the Polynesians and Maori, and they served as important navigational markers. They were named after Portuguese navigator Ferdinand Magellan, who was the first European to sight them during the first circumnavigation of the Earth between 1519 and 1522. Magellan himself never completed the voyage. He was killed in the Philippines during the Battle of Mactan. But the Magellanic Clouds were later named in his honour. The Large Magellanic Cloud, the nearest of the pair, is 163,000 light-years away. Although it looks like an irregular dwarf galaxy, astronomers classify it as a disrupted barred spiral galaxy. It's about 14,000 light-years in diameter and contains about 10 billion times the mass of the Sun. One recent estimate of the total mass of the Large Magellanic Cloud suggests it's about 1/10 the size of the Milky Way. The Small Magellanic Cloud is slightly lower and to the west and is located about 200,000 light-years away. It's classified as an irregular dwarf galaxy, about 7,000 light-years wide, with about 7 billion times the mass of the Sun. Astronomers speculate that it was once a small barred spiral galaxy, but had become disrupted by the gravitational tidal perturbations of the Milky Way. The Large and Small Magellanic Clouds are separated by roughly 75,000 light-years. They were considered the closest galaxies to the Milky Way until the 1994 discovery of the Sagittarius Dwarf Elliptical Galaxy and then the 2003 confirmation that the Canis Major Dwarf Galaxy is actually our nearest galactic neighbour. Interestingly, only a fraction of the Magellanic Cloud's gas seems to have coalesced into stars, and they're both thought to contain what should be large dark matter halos. The Magellanic Clouds have both been greatly distorted by gravitational tidal interactions. A flow of high-velocity neutral hydrogen gas known as the Magellanic Stream leading arm extends over 600,000 light-years from the Large and Small Magellanic Clouds through to the galactic south pole of the Milky Way. Its composition suggests that it's mostly composed of gas from the Small Magellanic Cloud, which is less massive and so less able to hold onto its gas. A separate stream of neutral hydrogen, known as the Magellanic Bridge, links the two Magellanic Clouds. Observation shows there's a continuous stream of stars throughout the bridge, with a greater concentration of stars in the western section of the bridge. Scientists first suggested that the Small Magellanic Cloud was not one but two dwarf galaxies back in the late 1980s, but it's taken until now for more evidence supporting this hypothesis to come to light. The new research involved astronomers mapping the motions of stars within the Small Magellanic Cloud using data from the European Space Agency's Gaia spacecraft. This allowed them to study the average velocity of stars in various parts of the galaxy. They also examined the interstellar medium, the gas between stars in both the Large and Small Magellanic Clouds, using data from the Australian Square Kilometre Array Pathfinder radio telescope in outback Western Australia. And finally, they analysed spectroscopic data from the Apogee survey being conducted at the Apache Point Observatory in New Mexico. By combining all this information, the authors found two distinct and separate chemical compositions within different areas of the Small Magellanic Cloud, and the stars within each of these areas were moving at different velocities. Those in the foreground galaxy, at least from our viewpoint here on Earth, were moving faster than those in the background galaxy, even though both parts had roughly the same amount of mass and were interacting in a similar way with the Large Magellanic Cloud. The authors say that taken together, all this evidence suggests that the Small Magellanic Cloud is actually two very separate and unique galaxies, one located directly behind the other relative to the Earth. They say the closer of the two is approximately 199,000 light-years away, while the more distant is somewhere around 215,000 light-years away. It's a fascinating hypothesis and will undoubtedly lead to a great deal of peer review. We'll keep you informed. This is Space Time. Still to come, a new study suggests the dwarf planet Eris is possibly squishier than expected, and NASA says its new PACE satellite is slated for launch on February the 6th. All that and more coming up on Space Time. A new study claims that the distant Kuiper Belt dwarf planet Eris is likely to have a malleable or squishy internal structure. The findings, reported in the journal Science Advances, are based on new computer model simulations of the 2,326 kilometre wide body's internal structure. Eris has played an important role in astronomy's understanding of our solar system. See, its mass is 0.28 times that of the Earth, but 27% greater than that of Pluto, although Pluto is slightly larger by volume. Also, both Eris and Pluto have a surface area that's comparable with the area of Russia or South America. But Eris is around 50% further away from the Sun than what Pluto is, placing it far deeper within the Kuiper Belt. The Kuiper Belt is a ring of frozen worlds, comets and icy debris that circles the Sun out beyond the orbit of Neptune. It was the discovery of Eris, and the fact that it is so similar in many respects to Pluto, including size, that prompted astronomers to have a rethink about the definition of a planet. And it was this which ultimately led to Pluto being demoted from planetary status and reclassified as a dwarf planet, the same category in which Eris was placed. The new research by Francis Nemo from the University of California follows a meeting with Michael Brown, one of the discoverers of Eris, at the California Institute of Technology in Pasadena about 6 months ago. Nemo realized that some of Brown's new unpublished data could help reveal new information about the properties of Eris. And so the pair worked on models over the next few months, eventually finding that Eris and its moon Dicnomia are tidally locked, with the same sides of both bodies always facing each other. Nemo says that happens because Eris is getting spun down by the tides that the little moon's raising on it. And the bigger the moon is, the faster the planet spins down. Astronomers can use the spin and orbital characteristics of planets and their moons to infer properties of their internal structures. But until recently, astronomers didn't have an estimate for the size of Dicnomia. It was Brown's then unpublished data which changed this by revealing that Eris' moon must have been below a certain mass. And it was the upper limit of that mass which provided a crucial piece of information. Dicnomia, it turns out, had an estimated diameter of 615 kilometres, about 24 to 29% of Eris' diameter. Nemo says as soon as he knew this, he could then start to undertake some new calculations. The main unexpected result of Nemo and Brown's new model is that Eris is surprisingly dissipative or squishy. The authors determined that Eris has a rocky core surrounded by a layer of ice. And the outer shell of ice is likely convecting, unlike the conducting shell of Pluto. The rock contains radioactive elements which are producing heat. And as the heat escapes, it drives the slow churning of the ice. Nemo says Eris, therefore, behaves less like a rigid object and more like a soft cheese. Oh, and that upper limit on the mass of Dicnomia, well, that came from measurements made by ALMA, the Atacama Large Millimeter Submillimeter Array Telescope in Chile. Nemo says Eris would probably look fairly smooth on the surface because the constantly churning ice flow would keep any topography away. This is Space Time. Still to come, we take a look at NASA's new PACE satellite mission to study the clouds, and later in the science report, as the world gets more and more unstable, Russia completes its delivery of tactical nuclear weapons to Belarus. All that and more still to come on Space Time. NASA has slated February 6th as the opening launch window for its new Plankton Aerosol Cloud Ocean Ecosystem, or PACE, satellite. The mission aboard a SpaceX Falcon 9 rocket will take off from Space Launch Complex 40 at the United States Space Force Base in Florida. Once in orbit, PACE will scan the Earth, offering new insights on airborne particles, including sea salts, smoke, human-made pollution, and dust, collectively known as aerosols. It'll do this by observing how these aerosols interact with light. You see, some of the same properties of light and optics that make the sky look blue and that cause rainbows can also help scientists unlock mysteries about cloud formation and the effects of tiny particles in our atmosphere. The data scientists gather will provide better answers to key questions such as how aerosols affect cloud formation and how ice clouds and water clouds differ. Understanding the nature of airborne particles and clouds is also crucial for deciphering how climate and air quality are changing. The PACE spacecraft will use two cutting-edge polarimeters, instruments that measure light properties. These include characteristics of light that people see with their own eyes, things like colour, but also properties that people can't see, like polarization. PACE polarimetry lead scientist Kirk Noble-Specie from NASA's Goddard Space Flight Center in Greenbelt, Maryland, says polarization is something humans don't have an intuitive sense of because our eyes don't see it. He says if you saw the world through eyes that could see polarization, you'd see rainbows everywhere. See, light leaving the sun moves in all directions like a wave. This is called unpolarized light. But when the light interacts with something, like a cloud or an aerosol particle, it can oscillate more in one direction than another. In other words, it becomes polarized. And it's this quirk of light behavior which helps scientists learn more about the characteristics and interactions of aerosols and water droplets in the sky. Polarimeters measure the angles at which the light is polarized, and that reveals specific characteristics of whatever the light had bounced off. With these instruments, scientists can piece together the size, composition, abundance, and various other traits of the different particles within the atmosphere. The two polarimeters on PACE, HARP-2 and SPEX-1, have complementary differences in what they measure. HARP-2 was built by the University of Maryland and will observe 4 wavelengths of light from up to 60 different angles. SPEX-1, built by the Netherlands Institute of Space Research and Airbus, will peer down over a narrower patch of the sky, using 5 different viewing angles, but looking at light at hyperspectral resolution, the full range of colours in the rainbow. Together, these two polarimeters will offer a picture of Earth's atmosphere in unprecedented detail. Travelling at an orbital speed of 7 kilometres per second, PACE will be able to scan the entire planet every 2 days, gathering immense quantities of data on the chemical composition, movement and interaction of aerosols and clouds. Scientists want to measure properties of aerosols because they affect climate. Not only do they reflect light back into space, they can also absorb it, and both those play an important role in how much of the sun's energy reaches the Earth's surface. Aerosols also affect cloud formation and properties, but the details of these relationships are not fully understood. The data that PACE collects will help to clarify some of these unknowns. The new polarimetry data will also offer some real-time insights into air pollution. PACE will allow scientists to identify aerosols while also deciphering what they mean for air quality. This report from NASA TV.
If we were to see the world with polarization-sensitive eyes, the sky would not be blue. Grass would look gray. There'd be all sorts of strange things that would be happening. What we reveal about the environment with polarization is really kind of another dimension of information.
The PACE mission holds the keys to unlock that dimension with 2 toaster-sized instruments called polarimeters. And polarimeters like these measure the polarization of sunlight.
So generally, sunlight has a combination of different directions. Polarization is some preference for an oscillation direction.
The ability to detect the specific direction sunlight reflects back to PACE's instruments will give us more information about clouds and tiny atmospheric particles called aerosols.
The aerosols are really important to human health. So that's why we need to really quantify what is out there, like what type of aerosol there, and where they come from.
Various interactions with light in the environment, scattering events off of particles or surfaces can impose some preference in the light that they reflect in terms of the polarization nature.
The two multi-angle polarimeters were built by NASA's partners, both here and abroad. The Hyperangular Rainbow Polarimeter No. 2, or HARP-2, will measure atmospheric particles in one of its spectral channels in up to 60 viewing angles. Why so many angles?
So this is like a camera, like any other kind of camera, but instead of taking a picture at one particular geometry of what we would understand as light, it's looking at a scene from different angles.
We will move the different angles to the one single location. And in that way, we will collect the information at all the different angles.
And those different angles can contain information about what's present in the environment.
For instance, all these angles from HARP-2 can analyze the elusive cloud bow.
Cloud bows are slightly distinct from a rainbow. Rainbow is light scattering off of rain droplets. Cloud bows is light scattering off of cloud droplets, which are a little bit smaller. By being able to observe cloud bows with polarization, and if we very accurately measure the geometry in which this happens, the exact position of that cloud bow with respect to the sun in our observation, it tells us a lot about the size distribution of the cloud droplets. If we understand the size distribution of cloud droplets, we can understand things about the formation of clouds, how long they will persist, if they're going to turn into precipitation or not.
Polarization can also reveal the shape of sun glint, the pattern of sunlight reflecting directly off the ocean's surface. Sun glint patterns can tell us how rough or smooth the ocean surface is, which can determine wind speed at the surface.
Clouds also have an impact on climate, but the interaction between the two, there's many pathways in which aerosols can interact with clouds. Cloud droplets can form around aerosol particles more easily, and other things that are going on in the local situation. That complexity of the interaction between the two is one of the largest sources of uncertainty in understanding our global climate, and that's why we're making these measurements.
The data from PACE will allow researchers to tease out the species of aerosols, which will help fine-tune climate models so they make better predictions. PACE's other polarimeter, SPEX-1, will tackle aerosol retrievals and give us precise measurements of the angle, degree, and intensity of polarization. But processing the sheer volume of data has been its own mission. Each pixel of data the polarimeters measure covers about 5 kilometers square. In that space are hundreds, even thousands of observations at different angles, wavelengths, and state of polarization. In the course of one full day of orbits, those pixels pile up.
If you put them together, there will be more than 10 million pixels. That's huge challenge on both storage and computational powers.
To meet that challenge, the PACE team has turned to a kind of machine learning called a neural network emulator. Even before PACE gathers any data, the emulator has been trained with millions of simulations of the possible atmospheric conditions in that one pixel. With this emulator, what would take an hour for one pixel is now a matter of milliseconds, allowing PACE to process a seemingly endless stream of data for the mission and atmospheric researchers all over.
They will require a lot of measurement, especially if we can do that from a global scale with satellite. So we know where they come from, so we can trace their source. We probably can help to reduce its impact on the human health.
And in that report from NASA TV, we heard from Kirk Noble-Spessy, polarimetry lead scientist for the PACE mission, and Meng Gao, PACE polarimetry data scientist and software lead. Both are with NASA's Goddard Space Flight Center in Greenbelt, Maryland. This is Space Time. And time now to take another brief look at some of the other stories making news in science this week with a science report. Russia has completed its delivery of tactical nuclear weapons to Belarus. Belarus President Alexander Lukashenko made the announcement during a visit to the Russian city of St. Petersburg for the Supreme Eurasian Economic Council meeting. He didn't say how many nukes Russia was sending to his country, but he confirmed that the last delivery from the Kremlin occurred in early October. Russian President Vladimir Putin announced the move to station nukes in Belarus back in March last year. It was part of Moscow's ongoing threats against the West over their continued support for Kiev following the Russian invasion of Ukraine. Minsk aided Moscow in its invasion by allowing Russian troops to deploy across its southern border into northern Ukraine when the Kremlin first invaded back in February 2022. A new study has found that getting your period before you reach 13 has been linked to a higher risk of developing type 2 diabetes during midlife. The findings, reported in the British Medical Journal, also show that it's also associated with an increased risk of stroke before you reach the age of 65. The study's authors asked over 17,000 women between the ages of 20 and 65 when they began menstruating, and then compared their answers with whether these women had developed diabetes or some type of heart disease. They say the increased risk ranged from 32% if they were aged 10 or younger to 29% greater at the age of 12. The authors also found that a first period at age 10 or younger more than doubled the risk of a woman having a stroke before they reached the age of 65 with diabetes. Now, this kind of study can't directly connect starting your periods early with these issues. But the authors suggest that an earlier age for the first menstrual cycle may be one of the early life indicators of a cardiometabolic disease trajectory in women. Scientists have developed an ultra-high-speed signal processor capable of analysing more than 400,000 real-time video images concurrently. A report in the journal Nature Communications claims the team, led by Swinburne University, have developed a processor that operates more than 10,000 times faster than a typical electronic processor, which operates in gigabytes, reaching a record 17 terabits or trillions of bits per second. The secret to its remarkable performance lies in the integrated optical microcomb, which overcomes the bandwidth and energy limitations inherent in electronics. This photonic signal processor is undoubtedly a harbinger of the future, where high-speed, efficient data processing shapes every aspect of our lives. The new processor's efficiency and speed will have a major impact on artificial intelligence, machine learning, and robotic vision. The ability to process vast amounts of data in real time will lead to more intelligent autonomous robotic systems that can operate efficiently in real-world environments. The technology, therefore, has profound implications for the safety and efficiency of driverless vehicles, medical imaging systems, and it could even help find habitable planets beyond our solar system. The Australian Privacy Commission has launched an investigation into TikTok following claims the Chinese social media platform is still taking people's personal data without permission. It's been alleged that TikTok's using a tool called Pixel to harvest detailed profiles on people without their knowledge or consent. The data they're gaining includes addresses, driving habits, emails, messages, notes, address books, mobile phone numbers, and online browsing history. Other companies are using Pixel as well, but with permission. What's being claimed is that TikTok are data scraping without permission and through third-party apps, meaning you don't even need to be on TikTok or a subscriber to TikTok to be a victim. Back in April, TikTok was fined £12.7 million in the UK for breaching a number of data protection laws, including stealing the personal data of young children without parental permission and failing to use children's personal data lawfully. The investigation also found that more than 1 million UK kids under the age of 13 were on TikTok. That's contrary to its terms of service. TikTok is owned by Chinese company ByteDance, which has to answer to the Chinese Communist Party. China's 2017 national intelligence laws require organizations and citizens, including TikTok, to support, assist and cooperate with state intelligence and the Chinese military on request. The Australian government has banned TikTok from all official government devices over security concerns. The governments of Britain, Canada, France, New Zealand and the United States military have also done the same, following claims that TikTok was especially interested in data on politicians, government and military employees, journalists, defence contractors, and people working in essential and emergency services, such as security, hospitals, and electricity providers. With more, we're joined by technology editor Alex Zaharov-Reutt from TechAdvice.life.
The TikTok saga continues. Now we have claims that not only can the TikTok app track every keyboard input, which could include things like credit card details or passwords or other sensitive information, but also there's a little pixel that is on different websites, and somehow this is being used to track you and your activity on the web, even if you're not a TikTok user. Now, there are claims that this is no different to what a lot of the other social networking companies do. In China, they have a social credit system where if you don't live up to what the government thinks is the right thing for you to be doing, then you'll be denied the access to catch the train or catch a plane or do various things, which would be unthinkable for the government to block you from doing in most Western countries. So the question is TikTok spying on you? What are they doing with that information? And even if you're not a TikTok user, should they be allowed to collect this information on people around the world? And of course, you would imagine the answer is no. If you're not a TikTok user, why should you be spied upon? Now, personally, I use an app called OneBlocker on my Mac, my iPad, and my iPhone to block all the different trackers that are on many different websites and within apps themselves. And on Windows, there's things like Ghostery, and there's a number of other ad blockers and tracker stoppers that are meant to stop all these trackers in their tracks, as it were, from being able to collect information about you. And it really does come down to you needing to make the decision to use one of these trackers and to know how to disable the tracker should it be blocking things like comments or blocking certain things from certain websites from working, which some of these tracker blockers can do. But for the most part, they're very good, and they block ads and they block the trackers, and you can get a report as to how many trackers are being blocked. And in fact, even Safari inside of the Mac, iPad, and iOS browser now has a tracker blocker built in, but it's still better to use some of these third-party ones. So, as I said at the beginning of this interview, the TikTok saga continues unabated, and I don't think it'll ever really die down unless the West bans TikTok completely, which is also not necessarily the right response because a lot of people love TikTok and make money from it.
That's Alex Zaharov-Reutt from TechAdvice.life. That's the show for now. Spacetime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favourite podcast download provider, and from spacetimewithstuartgary.com. Spacetime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the Spacetime store for a range of promotional merchandising goodies, or by becoming a Spacetime patron, which gives you access to triple episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details. And if you want more space time, please check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as heaps of images, news stories, loads of videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, @SpaceTimeWithStuartGary on Instagram, through our Spacetime YouTube channel, and on Facebook, just go to facebook.com/Spacetime with Stuart Gary.
You've been listening to Spacetime with Stuart Gary. This has been another quality podcast production from Bytes.com.